Hello guys, welcome back to Math Zone African Motives. In this platform, we are going to focus on trigonometry, actually geometry, not trigonometry. This is just part of geometry, your analytical geometry, but yeah, it's just geometry. So we are just going to quickly rush through these questions. We just need to know how to attempt that these typical questions that you are given. So this is question number 3. Where we are given to consider fig 1 below. So this is the fig that we are given. We are given that A, B, C, D is a parallelogram. Take note, it's a parallelogram. Remember the properties of a parallelogram, that the opposite sides, they are parallel and equal. The opposite sides here, they are parallel and also equal. And also the diagonals, they bisect each other. So these diagonals that we see, diagonal AC, diagonal BD, they bisect each other at point M, which is the point of intersection of the diagonals. That is the midpoint of all the diagonals. It's a midpoint for both. Okay, so we are not going to waste much time. The first part on this part was to prove that the midpoint M of AC is equivalent to, okay, let me just take this one, is equivalent to minus half, and that is 2 marks for that. Okay, so the midpoint M, which is the midpoint of AC. Okay, where do we have A and C? This is our point A, as we can take A and C. Remember that the midpoint is given by this formula, so I'm just going to write this aside. This is 4.1. All right, remember that if you are to calculate the midpoint, that's the midpoint. In this case, you add the values of x together. That's x1 plus x2 over 2. The values of y together, then you divide by 2. So that's what you're going to have. So we are actually calculating the midpoint, which is the point M. So the point M, we are going to calculate x1 and x2. This is the midpoint of AC. So you can just say this is our x1, this is our y1, that's our x2, that's our y2. So x1 and x2, that's minus 2 and 1. So we're going to add minus 2 plus 1 over 2. Then we move on to y1 and y2, which is y1 is 1, y2 is minus 1. So it's 1 plus minus 2 over 2. So you can just simplify this on your calculator, but guys, minus 2 plus 1, that's minus 1 over 2. 1 minus 2, that's minus 1 over 2. So as we can check, this is proved. We can see that our M is truly minus half. So that's the point M. On 4.2, we are given a condition. So this is not like always they will tell you that use the coordinates of the midpoint. No, you are supposed to know that the midpoint is the same for the parallelogram. So they are saying use the coordinates of the midpoint M to determine the coordinates of the fourth vertex D. So as we can check on our diagram here, D is not having the coordinate. We are just given as XY. Okay, so this is what you're going to do. Remember, we said M is the common point for both. It's being shared by both diagonals. It's the midpoint of both diagonals. So that means we can find this same M that we have, which is minus half like this. The same M, we can find it. So this is 4.2. We can find it as the midpoint of B and D because we are referring to the diagonal BD. So this is your B and that's your D. So you're going to add the values of x together. At D, we've got x. So it is going to be x plus 2 over 2. You move on to y, you do the same thing, y plus the value of y at point B, which is 2, everything over 2. Remember, that's how you find the midpoint. You add the values of x together, you divide by 2. The values of y together, you divide by 2. So simply by doing this, it simply means these two are the same. You can equate minus half to x plus 2 over 2. So that's an equation that you're going to formulate. Minus half is equivalent to x plus 2 over 2. Then we move on to y. You do the same. Minus half is equivalent to y plus 2 over 2. But as we can see, guys, these two equations are actually the same. This equation and this equation are the same, only that here it's x, here it's y. So you can just solve one side. Then the value of x that you have is the same as the value of y that you obtained, because these two equations are the same. So I'm just going to utilize the first equation. Let's cross multiply to remove the fractions. 2 times minus 1, that's minus 2, is equal to 2 times x, which is 2x, 2 times 2, remember, it has to multiply everything, which is 4. So you can collect like terms, you can transpose 4 to this side, it will be minus 4. So minus 2 minus 4 is equal to 2x. Minus 2 minus 4, that's minus 6, which is equal to 2x. So you can divide by 2. So our x is minus 3. So as we can see, our x here is minus 3. But the same equation is the one that you can see on this other side. So even if you solve for y here, you're going to see that your y is going to give you a minus 3. So that's the point D. So which means the point D that we are referring to is going to be like this. Therefore, the point D, all right, so therefore our point D is going to be the value of x, which is minus 3, as to the value of y. Remember, a point is made of x and y. So this is our point D here. Okay, let me just do something here. Okay, it's just gonna show our point D here. We're going to write it as minus 3, minus 3. Maybe we might need to use this value later on. And also our M here, it was negative half, negative half. You never know, maybe we might need to use this later on. Okay, but that's what we had. So I'm just gonna erase this part so that we can use it to answer the other typical questions that we are given. All right, anyways, let's see, guys. I do not want to waste your time. I don't want to waste your time. Let us quickly rush through these questions. Okay, so that's it. 4.3. Determine the length of BC, and that's 2 marks. Okay, so let's see where do we have our B and our C. We have got B here and we've got C. So remember that the length of a line, so this is 4.3. The length of a line is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is what you're going to do. You're going to name your points. Remember, this is with B and C. So this is our B, and that's our C. So now we're gonna name these points. Let's just say this is our x1, y1. This is our x2, y2. So according to the formula, BC is equal to the square root of x2 minus x1. Our x2 is 1, so it's 1 minus 2 squared plus y2 minus y1. Y2 is minus 2. Take note, it's minus 2. So it's minus 2 minus 2 squared, like that. Okay, so this will be the length of BC. So you just leave your answer in set form, or depending with the values that you're going to have there. Okay, so let's just see. Let me just share the screen so that we can see our calculator here. All right, so let me just enable the calculator. So this is going to be the square root of 1 minus 2 in bracket squared plus another bracket, that's minus 2 in a bracket squared, like this. And this is going to give us the square root of 17. So that's the square root of 17 units. Okay, this is distance, so you leave it as units. So that was your BC. All right, 4.4, we are given calculate the angle of inclination alpha of the line BC. So we want to calculate the angle of inclination alpha. Do we have the gradient of line BC so far? We do not have this. Okay, I want to change this to this thing here. So as we can check, we do not have this gradient of BC, because for you to have the angle of inclination alpha, you must have the gradient of BC. But we never calculated this gradient of BC, we never. So that means we are forced to calculate first the gradient of BC, because we never calculated this. Why are we calculating the gradient? Okay, let me show you. This is 4.4. So let me show you here. We need alpha. This is your alpha. As you can see, it's an angle of inclination, the one that we are given here for BC. So we must understand that this alpha is equivalent to arctan, the gradient that you are given. In this case, we are referring to the gradient of the line BC. So that's why I'm writing as MBC. So the first thing is to calculate the gradient of BC, of which we know that the gradient of a line is equivalent to the change in y over the change in x. So that's y2 minus y1 over x2 minus x1. Okay, we listed our values before. Y2, that's minus 2. So it is going to be minus 2 minus y1. Y1 is 2 over x2. This is our x2 here, which is 1, minus x1, x1, which is 2. Okay, so that's a 2 there. So we are going to have minus 4. Here, minus 2 minus 1, that's minus 4 over minus 1. So it's going to be minus 4 over -1, that's a 4. So we are going to obtain 4. So this is the gradient of line BC. But I was saying that alpha, the angle of inclination, is equivalent to arctan, the gradient of that line. So that is the gradient of BC, which is 4. So our alpha is going to be arctan 4. So from your calculator, make sure that your calculator is in degrees. Okay, that's the first thing. So my calculator here is in radians. So I'm going to change to degrees, and that's degrees. Now it must show a D there on your calculator. There must be a D here. So that's arctan shift tan 4. So it is going, okay, so it is going to be shift tan 4, which is 75,963 and so forth. That's 75,960. So it's going to be 75,96 degrees. Okay, so that was the angle alpha on question 4.4, and that is actually 2 marks for that. And as you can see, guys, just 2 marks. Okay, so let's see the other part of the question, what we are given. So 4.5, we are now given to determine the equation. Okay, let me just try and adjust a little bit. Okay, determine the equation of the line in the form y is equal to mx plus c, which is perpendicular. Take note, we are given that the line is perpendicular to BC and passes through point A. Okay, so this A is a point. Okay, so the line is perpendicular to BC and passes through A. Okay, so let's start with the concept that it's perpendicular to BC. So we're going to write it down here. So this is 4.5. So so far, we are given that it passes through point A, and we have the point A in this case. We can check on our diagram. A, it's -2, 1. Okay, so that's our point A, which is -2, 1. All right, so I'm just going to write it somewhere here. So this is -2, 1. This line that we are talking about, it's perpendicular to BC. So the line and BC, they are perpendicular to each other. And we know that for the two lines, if they are perpendicular, the product of their gradients should be -1. The product of the first gradient to the other gradient is going to give us -1. Already we are given the gradient of BC. So it means we do not know the gradient of the line that we want to calculate its equation. So let's just say M1, we do not know the gradient of the line, but we know the gradient of line BC. So we know the gradient of BC. The gradient of BC, we calculated it before here. If you have to cross-check, this is the gradient of line BC, which is equivalent to 4. So if you multiply to 4, you must obtain -1. So what is the gradient of that line that we are supposed to calculate its equation? Just divide by 4 both sides. So the gradient of the line that we are supposed to calculate its equation is -4. Now we are given to calculate the equation, and we are given the format to use. So there are so many ways to use, but I actually love this way of using the format because you're asked to leave your answer in the form of y is equal to mx plus c. So it's an advantage to just use the formula direct because we are substituting already. You have the gradient m here represents the gradient, and our gradient is -1/4. So it is going to be -1/4x plus c, which is the constant. Okay. Now you want to find the value of c. What are you going to do? For you to find the value of c, you substitute the point A that you are given, because a point gives us the value of x and the value of y at that point. So our y in this case is 1. So 1 is equal to x. That's -1/4 times x, of which our x is -2, plus the constant of integration, which is c. So if we are to simplify this, -1/4 times -2, you can see that this one is going to give us 1/2 plus c. So to find the c, transpose 1/2 to the other side of the equation. That's 1 minus a half is equal to c. So c is equal to 1/2. So therefore, our equation in this format is going to be y is equal to mx, which is this part that we have wrote before. So we are going to substitute here, where we have got -1/4x plus c. Our c is 1/2. All right, so this is the equation that we are going to obtain for the line that we are given in this case. All right, so take note, guys, on how to simplify and on how to calculate the equation of a straight line. All you need in actual sense is to have the gradient. Once you have the gradient and the point, then you can calculate your equation. Like I said, there are so many ways that you can use. Maybe you were taught another way, but you must find the same answer just like the one that I got there. All right, so that was it on question 4.5. Okay, now we are on question 4.6, which is the last part of the question having 3 marks. Determine the coordinates of point of intersection of the line through A, take note A, which is -1, -2, 1, which is parallel to the y-axis. Okay, let's take that part first. There is a line which is at point A. This is our point A here, and it's parallel to the y-axis. This is the y-axis, guys. This is your y-axis. So a line parallel to the y-axis is going to be drawn like this. It is going to be like this, passing through point A. That's a line parallel to the y-axis. So this line, it's actually a vertical line, and we know that all vertical lines, their equations are written in terms of x. Okay, let's take example of the y-axis. In the y-axis at this point, we've got a 0, where we can write this equation as x is equal to a 0. So it means if a line is passing through point A, where at point A, x is -2, it means the equation of the line, it's x is equal to -2. That's the equation of the line. If it is parallel to the x-axis, then the equation is supposed to be y is equal to a certain number where it passes through that point. So this one, it's x is equal to -2. So that's the equation of the line that passes through point A. So at point A, we are given the equation of the line that's x is equal to -2. And parallel to the y-axis, and the line 2y minus x is equal to, so there's another line of 2y minus x, which is equal to 5. So for you to find the point of intersection of these two lines, there is a line of x is equal to -2. There is a line of 2y minus x, which is equal to 5. And at the point of intersection of these two lines, these two equations are equal. So I can simply suppose already I have the value of x. So I can just simply substitute the value of x into x on the other equation, because this is like your equation 1 and this is your equation 2. But on equation 1, already x is equal to -2. So I'm going to utilize the second equation. In place of x, I'm going to substitute -2. So it's 2y minus x, and x is -2 like this, which is going to give us 5. So take note, minus and a minus, that's a plus. So that means we are going to have 2y is equal to, if I transpose this to the other part of the equation, it is going to be like this. 2y is equal to transpose +2, because it's a positive, so it will be -2. And 5 minus 2, that's 3. So you can divide by 2 by 2. So that means y is equal to 3/2 at the point of intersection. So at our point of intersection, guys, x is -2, y is 3/4. So therefore, our point of intersection is going to be -2, 3/2. Remember, a point is made of x followed by y. So this is going to be our point of intersection. All right. So that's what you're going to have at the end. So these are the typical questions, guys, that you are supposed to be revising along the lines, because they are going to ask you these types of questions, or these typical questions in your final exam. So you must be very, very careful. You revise as much questions as you can, work with past exam papers and also your textbooks as much as you can, guys, as you revise for the final exams, which are ahead of time. But for now, that's it, guys, for Maison African Motives, still on engineering maths, netted engineering, mathematics N3, till we meet again.